In example 6, this is a height of a rocket problem. And really, it's just asking um, when, determine the time, when the rocket reaches its maximum height. And then it wants us to find the maximum height. Well, let's read the entire problem. A model rocket is launched with an initial velocity of 100 feet per second from the top of a hill that is 20 feet high. Its height in feet t seconds after it has been launched is given by the function s of t equals negative 16t squared plus 100t plus 20. Okay, well, we're used to working with this function and finding a vertex. So let's write the function down. S of t equals negative 16t squared plus 100t plus 20. Okay, so we're used to finding the vertex, and when we find the vertex, just say vertex xy. When we find the vertex, the x value is when we have the maximum or minimum. The y value will be the maximum or the minimum. So if I can just take this function s of t and find the vertex, I'll have the time, and then I'll have my maximum height. Okay, so to find the vertex of the function, you say the x value will equal opposite b over 2a. And then once you have the x value, you can plug it into the function and find the y value. So this function is in the form of ax squared plus bx plus c. So b is 100. That means opposite b is negative 100. A is negative 16. So right here we're going to put 2 times negative 16. This simplifies to a positive number, and it's going to be 25 over 8. Okay, so let me do this in a different color real quick. So far, remember, we're finding the vertex, because if we have a vertex, that's going to tell us when our maximum and minimum happens and what exactly the maximum and minimum is. Okay, so the vertex, so far I have the x value, 25 over 8. 25 over 8 is about 125. 25 over 8. I need to find the y value. So I know when that minimum or maximum happens. I don't know what it is. I don't know if it's a minimum or a maximum. But I know it does happen at that x value of 25 over 8, which is 3 something. Okay, so now to find the y value, all I need to do is plug that fraction, that x value, into the variable in the function. So remember, we had negative 16 t squared. Well, instead of t, I'm going to put 25 over 8. Plus 100 times t. So instead of t, I'm going to put 25 over 8. Plus 20. When I type this in the calculator, okay, I'm going to first square this fraction, 25 over 8. And then I'm going to multiply it by negative 16. And then you take that figure and add that 100 times 25 over 8 and then add 20 to it. When I do this, it's not very pretty, but the simplified fraction is 705 divided by 4. and that is about 176. 0.25, 176.25. Okay, so I'm just going to write that exact figure. The decimal wasn't needed, but I just like to know about what it is. 705 divided by 4, n as the vertex, and I'm done. Okay, I know when. I know that I have a maximum. Um, the maximum is the y value, 705 over 4. And it happens 25 over 8. Let's see the unit of time we used. 25 over 8 seconds after the rocket is launched.